Good day, students. Welcome to math.serve.com. In this clip, we're going to be continuing our coverage of the applications of differentiation problems. This is part 2. We're going to take a look at problems 4 to 6. If you want to practice the concepts covered in this presentation, you can make use of the Larson AP Calc textbook, section 3.1, problems 4 to 6 to demonstrate that you've mastered the contents covered in this presentation. Alright, let's take a look at question number 4. The instructions are the same as in part 1. So it reads, for the given functions, find the value of the derivative at the specified max or min or extremum. Okay, so in the graph provided here, the function for the graph is x times the square root of x plus 2. So we are to find the extremum at the specified, we are to find the derivative of the specified extremum. Alright, so we have two extremum here. The first one is this right here is a relative maximum, and this point right here is the absolute minimum. Okay, so let's go ahead and write them down. So the extremum which is a relative maximum and an absolute minimum are located at x equals -2 and x equals -4/3 respectively. Alright, so let's label it on the graph. This point right here, this end point, is a relative max, and this extremum down here, this point is an absolute minimum for this function. Okay, so this is an absolute min and is located at x equals -4/3. Alright, so what are we asked to do? We want to find the derivative at the extremum. Okay, so the derivative at the extrema are f prime of -2 and f prime of -4/3. So we're just basically going to evaluate what the derivative of this function is at these two values, -2 and -4/3. Alright, before we get started, let's review the steps to find the derivative at a specified point again. Alright, so steps to find f prime of a. Alright, if you're looking for the derivative at a specified point, the process can be broken up into two parts. Okay, so f prime of a is determined by first computing the derivative of the original function. So you find, so let's call this part 1. So firstly, you find the derivative of the function. Find f prime of x, and then you wrap things up by computing the value of the derivative at the specified a value. So think about calculus first, and then algebra or arithmetic comes second. Alright, so that's what we're going to do here. So the first part in the process is to find the derivative of the function. So part 1, we're going to find f prime of x. Okay? The original function under consideration is x times the square root of x plus 2. Now, if you notice, we have the product of two functions here, u times this monomial, linear monomial, times this radical function v. Okay? So the first thing that will come to mind is the use of the product rule, but we don't want to use that rule quickly. Okay? We don't want to be in a haste to use the product or quotient rule. We always want to ask ourselves, is there a way we can rewrite the problem to avoid using the quotient or product rule in order to simplify the computation process. If you look at this particular setup right here, there is no simplification that can be carried out to avoid the product rule. So we are stuck with that. So let's go ahead and apply the product rule here. So f prime of x is going to be the derivative of x times the square root of x plus 2. Okay, so we're looking at u times v prime. So what's the derivative of u times v? The product rule is as follows. It's v times u prime plus u times v prime. Alright, let's apply that here. We're going to have v, which is the radical function, root x plus 2 times the derivative of the linear monomial, x prime, plus u, which is x, times the derivative of the radical function, root x plus 2 prime. Okay. Alright, let's go ahead and differentiate where applicable. Bring down root x plus 2. The derivative of x to the first power is just 1. You power this down, and then 1 minus 1 is 0. X to the 0 is 1. So we have root x plus 2 times 1. Alright, plus. Now we're going to have to differentiate root x plus 2. Bring down the x. Now, this is a composite function. Alrighty? So since we have a composite function, we're going to have to use the chain rule to differentiate this. So let's extract the problem to the side. So we have root x plus 2. Okay, the outer function, let's call that f of x. F of x is the radical function. And then the inner function is the linear binomial x plus 2. Alright, so we know the chain rule. Derivative of the outer evaluated at the inner times the derivative of the inner. So if we differentiate the outer function, derivative of root x is 1 over 2 root x. And then differentiate the inner function, derivative of x plus 2 is just derivative of x, which is 1. And the derivative of 2 is 0. Alright, so what we're going to do is take the inner function and plug it into the outer, derivative of the outer, sorry, and then multiply that by the inner function, the derivative of the inner function, which is 1. Alright, so when we put everything together, the derivative of this function, root x plus 2 prime, is simply going to be 1 over 2 root x plus 2 times 1. Alright, so we can go ahead and insert that value here. We have 1 over 2 root x plus 2. Alrighty. Now we can go ahead and evaluate the derivative at this point in time. But what I want to do is I want to show you how to simplify this sum of expressions completely. Okay, a nice little algebra review for you. So we have the square root of x plus 2 plus x over 2 root x plus 2. So if this were a multiple choice question on the AP exam, for instance, and it was simplified completely, how do we proceed with this so that we have the expression simplified completely? We have to combine these two fractions, express the first radical as a fraction, and I want to find the LCD. Okay? The LCD of 1 and 2 root x plus 2 is 2 root x plus 2. So we're going to multiply the fraction on the left by 2 root x plus 2 on the top and 2 root x plus 2 on the bottom. When you carry out that multiplication, you will have on the top 2 root x plus 2 times root x plus 2 is simply going to be 2 times the quantity x plus 2. Alright, and then over 2 root x plus 2 plus x over 2 root x plus 2. Now that the denominators are the same, we can combine them together. Distribute the 2, you have 2x plus 2 times 2, 4, plus x all over 2 root x plus 2. Alrighty, so the derivative in its simplified state, f prime of x, is 3x plus 4 divided by 2 root x plus 2. Alright, so we're done executing step 1. Let's move on to step 2. We want to evaluate the derivative at the extremum, okay? At the extrema. So the first extrema is negative 2. So part 2, let's break it into 2a and 2b. 2a, we want to evaluate the derivative at the first extremum, which is negative 2. So let's do it. The derivative is 3x plus 4 over 2 root x plus 2. So we're plugging in negative 2. So f prime of negative 2 is going to be 3 times negative 2 plus 4 over 2 root negative 2 plus 2. Okay. And then in the numerator we have negative 6 plus 4, which is negative 2. In the denominator we have 2 times root 0, which is just 0. And it's undefined. Okay. So f prime of 2 does not exist. F prime of negative 2 is non-existent. Let's go ahead and find the derivative at the second extremum. So for 2b, we are now going to evaluate the derivative at negative 4 thirds. Okay, f prime of negative 4 thirds is as follows. So to carry this out, the derivative again is 3x plus 4 over 2 times the square root of x plus 2. So let's go ahead and plug in negative 4 thirds here and see what happens. F prime of negative 4 thirds gives us 3 times negative 4 thirds plus 4 all over 2. Let's make this 2 here bigger so it doesn't look like an index. So we have a big 2 here. Alright, so 2 root x plus 2. So we have negative 4 thirds for x plus 2's place plus 2. We can write 2 as, so if this is 2 over 1, we can write that as 2 over 1 times 3 over 3, which is the equivalent form is 6 over 3. Okay? And then if we simplify, we have negative 4 plus 4 in the numerator. In the denominator, we have 2 times, if you subtract this, root 2 thirds. And in the numerator, we have 0 over 2 times root 2 over root 3. If you want to simplify a radicand, if you have a fraction as a radicand, you always break them up and then you rationalize the denominator. In this particular problem, the numerator is 0, so we don't have to bother ourselves simplifying this. Alright? Or else we just drop, change, flip, multiply, and simplify. But in this particular case, we can clearly see that f prime of negative 4/3 is equal to 0. Alright? So our final answer, the derivative at the extrema, f prime of negative 2 does not exist. We have a kind of sort of like a vertical tangent here, and then f prime of negative 4/3 is 0. So that's expected. Anytime you evaluate the derivative at an extrema, you will at an extremum you end up with either 0 or the situation where the derivative does not exist. Alright, let's take a look at question 5. We have the graph of the function. So for question 5, we have f of x equals quantity x minus 3 raised to the 2/5. Alright, so let's get started with this. This is the extrema right here. The extremum is an absolute minimum. Okay, so let's go ahead and write it down. The extremum, an absolute minimum, is located at what? Is located at x equals 3. Okay, so the task, we're to find the derivative at the extremum. The derivative at the extremum is what? Is f prime of 3. Alright, so let's start out with part 1. We want to find the derivative of the function. Let's find f prime of x. Okay, alright, so we have the function f of x equals quantity x minus 3 raised to the 2/5. Now, what type of function is this? You notice we have an outer and an inner function. This is a composite function. Anytime you have a composite function, you use the chain rule. Okay? So let's go ahead and do it. So we want to find f prime of x, which is the derivative of x minus 3 raised to the 2/5. Alright, so let's break it up. Inner and outer function. Let's call the outer function f of x. The outer function is x to the 2/5. And then the inner function, let's call that g, and it's the linear binomial x minus 3. When you differentiate the outer function, f prime of x, use the power rule. You have 2/5 x to the 2/5 minus 5/5. 2/5 minus 5/5, or minus 1, is negative 3/5. G prime of x is the derivative of x minus 3, which is just 1. So what we're going to do is we're going to take g and plug it into the derivative of the outer and multiply the answer by the derivative of the inner. That is the chain rule. Okay? So the derivative f prime of x is going to be, so if we plug this in here, it's going to be 2/5 times the quantity x minus 3 raised to the negative 3/5. This is the derivative of the outer evaluated at the inner times the derivative of the inner, which is 1. Let's simplify this. Applying the reciprocal property of exponents, we can reciprocate this quantity with a negative exponent. So we have 2 in the numerator divided by 5x minus 3 raised to the positive 3/5. Alrighty, so that's the derivative. Now let's proceed to determining the value of the derivative f prime of x at the given extremum. Alright, so part 2, we want to evaluate f prime of, what was it again? 3, I think it was 3. F prime of 3. Okay? So for your recollection, f prime of x is 2 over 5 times x minus 3 raised to the 3/5. And then let's find the derivative at that point. So it's 2 over 5 times 3 minus 3 raised to the 3 over 5. And then that gives us 2 over 5 times 0 raised to the 3/5. And then it's simply 2 over 0, which is undefined. So basically the derivative at the extremum does not exist. Remember, at an extremum, the derivative, if it's local, if the extremum is local, the derivative is going to be either 0 or non-existent. If you take a look at the graph, can we draw a line tangent to this curve at this point? The answer is no, it's impossible to accomplish. That's why we have a non-existent derivative at that extremum, because you have a cusp right there. Alright, let's take a look at question number 6. We have an absolute value function given by f of x equals the absolute value of x minus 2 plus 3. Okay? Alright, in this particular case, let's go ahead and get started. The extremum, an absolute minimum, is located at, where is located at x equals 2. So this value right here, this value is the value of the, this point is the absolute minimum. Okay, and is at x equals 2. So you know how the absolute value function behaves, right? So it's going to just increase to the left and right, and this is the lowest point, the absolute minimum. Alright, so let's get started with the problem. What are we looking for? The derivative at the extrema is what? The derivative at the extrema is f prime of 2. So let's get started with part 1. Part 1, we want to find f prime of x. So the function f of x is equal to quantity x minus 2 plus 3. The derivative, we can just do term by term differentiation. So this first expression here, we can differentiate that first. The derivative of the absolute value of x minus 2 plus the derivative of 3. Alright? So we're going to be using the chain rule here because we have a composite function for the absolute value. Okay? We have the absolute value function on the outside and then a linear binomial on the inner. So let's go ahead and decompose this one right here. For this one, f of x is the outer function, and then g of x is x minus 2. F prime of x, remember the derivative of absolute value of x is the absolute value of x over x, or x over the absolute value of x. It doesn't matter. G prime of x is equal to 1. So we're going to plug in the derivative. We're going to plug in the inner function into the derivative of the outer. So there are two x's here. So this inner function goes into those two x positions. And we'll multiply that by g prime, which is just 1. Okay, so the derivative of x minus 2, the absolute value of x minus 2 is going to be the absolute value of the inner function x minus 2 over an inner function x minus 2 okay, times the derivative of the inner function, which is just 1. That's the derivative of the first part. Now what's the derivative of 3? Rate of change, instantaneous rate of change of a constant function is 0. Okay? So we have our derivative. We have part 1 completed, which is just the absolute value of x minus 2 over x minus 2. You can write it as x minus 2 over the absolute value of x minus 2 is still the same thing. Alright, to finish things up, we're going to go ahead and evaluate that derivative at the specified extremum. Okay, so we're going to evaluate f prime at the specified extremum, which is 2. Alrighty, so our derivative is the absolute value of x minus 2 over x minus 2. So as a result, f prime of 2 is going to be the absolute value of 2 minus 2 divided by 2 minus 2. And then 2 minus 2 is 0. We have absolute value of 0 over 0. This is undefined. So that helps us to see that the derivative at 2 does not exist. Okay, it's a non-existent limit. So that's that. Now, how well have you mastered the content of this presentation? Well, to demonstrate mastery, you can go ahead and try out the practice problems in the AP Calc Larson text. You want to try out section 3.1 and then attempt problems 4 to 6. Okay? Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of calculus, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any AP Calc AB question in general, just place your question in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to the rest of this review series. More clips, tools, and great resources to help you be successful in AP Calculus can be found on math.serve.com. Go ahead and check it out. Thanks again for watching and have a wonderful day.